This is the geometry review for Unit 4. Here for number 1, we're going to complete the congruent statement. So we're looking for the order. We notice that the 1 ticker is your R and your X. Your 2 ticker is your Q and your Y, and the 3 ticker is the S and the Z. Those have to be in the corresponding orders. So since they say QRS for the first triangle, QRS, they went in the order of 2, 1, and 3. So we have to say Y, X, Z. For this congruent statement, A, B, C, D, notice you don't use a figure for a quadrilateral, but A, B, C, D, they're going from A to the 90 degree and around the corner. So the A had 1 tick mark to the 90 degree and around the corner. So this is going to be E, G, H, F. In the diagram, we know the 2 triangles are supposed to be congruent. So we're going to find the values of X and Y. Notice, one thing for sure is that you realize that this is an angle value. It's a degree. It's not a side length. It's a degree. So side, or angle actually, G, is supposed to match with angle C. G and C are supposed to match up. So C is 119, and G is 8Y plus 39. We're going to equal them to each other if they're supposed to be corresponding parts, and corresponding parts are congruent if the polygon is congruent. So we get 80 equals 8y, divide by 8, and we get y equals 10. Next we're going to look for the value of x. And x, we see x is a side length of AD, and over here it's also a side length of HE. Now the question is, are they related? So we look up here and we see that AD is your first and last letter, EH is your first and last letter. So I know that 6x minus 12 is supposed to be the same as 3x plus 9. So we'll subtract our 3x over to get 3x, and then we will add 12 the other direction to get 21. And divide by 3 gives us 7. So x is 7, y is 10. Here we're supposed to find the value of x. Well, x is with D. E is 90 degrees. F is unknown. Here y is unknown. 90 degrees. Are these 2 triangles congruent to each other? It doesn't say it in the given information. But if you notice, they're both right triangles. The hypotenuse is the same. And the leg is the same. So using RHL, I know the triangles are congruent. And if triangles are congruent, then I know this is supposed to be 2x also. So the acute angles of a right triangle are complementary. I know they add up to 90. Or you could say all 3 angles add up to 180. X plus 2x equals 90. So x is going to be 30. Here we're going to state the congruence that is needed to prove the 2 triangles congruent with the given postulate. So what's the other piece that would need to be known? R, we know we have a right triangle. H is your hypotenuse. The hypotenuse, remember, is the side that is across from the 90 degrees. So we have two hypotenuses. So we need to know that AC is congruent to DF. That's the missing congruence that needs to be known. Here, if we're going to prove it by angle side, I would need to know a third bit of information that is congruent. I have the two A's, but I don't have the S. You have options here. You could say that BC is congruent to EF because BC and EF are in corresponding locations. The two angles and the side that's called non-included is the excluded side. Or you actually could have used this excluded side. AB that goes with DE. Knowing either one of these corresponding sides being congruent would be enough for us to prove the triangle's congruent by angle side. Which method, the 5 different ways, can we use to show that these triangles are congruent? Well, they both have a right angle. So we could call those angles to be congruent, or we could call the triangles right triangles. We have to see what other information they give us. They've given us the side next to it, but they haven't given us a third bit of information. But of course, they have the reflexive side, and this would be considered the hypotenuse. This would be considered the leg. So we would prove these congruent by R, H, L. Here, of course, we know the angles are vertical, so they have the single tick marks and then the two tick marks. So this is clearly, with nothing extra to show, angle side. Two A's and the non-included side. Here we have two sides, two angles, but I don't have another bit of information. I'm not certain that this is a midpoint. There's no information that tells me this has to be perpendicular. You might be able to come up with that conclusion, but here it's not telling us that. But what I know for sure is that I have the reflexive side. So this would have to be side, angle, side. On the next side, we're going to decide whether the triangles can be proved congruent by the given information. Alright, so if we know that LMN is congruent by CBA, do we know for sure that we can do this by RHL? Well, if this was a 90-degree angle, this would be a leg and that would be a hypotenuse. It would work out great. MN, AB, BA, order's perfect, but we don't know that's a right angle. It's not known if angle M or angle B are right angles. We don't know that. So no, we cannot prove the triangle is congruent. Here we see that we have a pair of angles that are the same, another pair of angles that are the same. Perhaps they're both the same together. But we need another side, and that would be the reflexive side. Now, angle, side, angle. So yes, these triangles are congruent using angle, side, angle. Okay. When we look here at number 8, we're supposed to match. Number 1's a pretty easy one with all 3 sides. So that's going to be D. RHL has to have a right angle, right triangle. So of course that's that one. 2 sides and the A. The only way that that can be done is to have the A in the middle. That would be that one. Now it's these 2 final ones that get a little tricky. You have 2 A's and an S. 2 A's with the S in the middle, and 2 A's with the S not in the middle. So if you're not in the middle, you've got to be sure to pick the 2 A's with the S on the outside. And if you are in the middle, you have to pick the 2 A's with the S in the middle. Number 9. In the diagram, the triangles are congruent. Okay, we got to trust them. They say the triangles are congruent. Doesn't look like it, but we'll trust them. The big challenge is trying to figure out why are they congruent, or how, more importantly, how are they congruent? What letters go where? Which ones team up? Which ones are considered corresponding angles? So the 47-degree angle and the 47-degree angle, they correspond to each other. The 58 and the 58 correspond with each other. So I know that triangle, name this one any way you want, FDE has to be congruent with WUV. And it helps us a lot to know the congruent statement, so you know what parts are supposed to match up. So what is supposed to match up with the V? So we look at angle V, and it's the last letter, so it's supposed to match up with the E. But I don't know what angle E is. Any suggestions? We know that this is supposed to add up to 180. So if we take 180 and subtract the 58, I'm going to get 122. And then if I subtract the 47, so we get 75. That'd be 111 plus 12, give you 122. So this is 75 degrees. Well, E and V match. So we have to set them equal to each other. 75 is supposed to equal 5x. Divide by 5, and we know that x equals 15. Y plus 3, that's ED. Well, ED is your last 2 letters. It has to match with UV. UV is 6. So Y plus 3 has to equal 6, and we subtract it. So I figured out what X is, I figured out what Y is. But some of you may have noticed I didn't use this Y. I didn't use the Y plus 5. It shouldn't matter. Let's look. WU. WU is the first 2 letters. It corresponds with FD, the first 2 letters. So Y plus 5 has to equal FD, which is 8. So when you subtract it, and you get 3 also. So of course, y is 3. You didn't really have to do it twice. So x equals 15 and y equals 3. So our congruent statement, we've already said, I guess, FDE is congruent to triangle WUV. Here we're supposed to state if the given pair of corresponding angles, corresponding sides or corresponding angles, or if they're neither. Well, the easiest thing to look at here would be a congruent statement. We know that the A goes with the D, the C goes with the F, so we're proving this by angle, angle, side. So triangle ACB has to be congruent to triangle DFE. And of course that would have been by angle, angle, side. Well, E and F are not considered corresponding sides. They're not considered, they're in the same triangle. So that's neither. E and B are in the same spot, so they are considered corresponding angles. AC is the first 2 letters, ED are not the first 2 letters, so this would be neither. D and C, D is the first letter, C is not the first letter. DE are the first and last, AB are the first and last. So those are corresponding sides or corresponding segments. EF is the first and last, BC is the first and last. Okay, here's our last page. We're working on 3 different proofs. We always look at the given information and we compare it to our picture. Angle K is supposed to be congruent to angle N. That's our given information. Angle KML. KML, that would be right here. The middle letter has to be the vertex. NML. NML would have to be right here. So we know that we have 2 angles in one triangle congruent to 2 angles of another. I have to come up with a third bit of information. So I'm trying to make my plan on how this proof can possibly work. I notice that ML is in both triangles. So by the reflexive property, I know that those have to be the same measurement. And once I have angle, angle, side, I can prove triangles congruent. So I'm going to write in my congruence, angles that are congruent. That was from my given. I'm going to state my reflexive property. And then now I'm ready to state that the triangles are congruent. We know by making our plan exactly what we were doing. From the given information, we needed to have one more bit so we can get our 3 pieces, which obviously in this case has to be a side, and then that was enough to prove the triangle is congruent. HI is labeled as congruent, JK is labeled as congruent, IJ, that's perfect. We're supposed to come all the way down here and talk about angle K and angle I. Why would those have to be congruent? Well, those can only be congruent if the triangles are congruent. And for the triangles to be congruent, I need to figure out one of the 5 ways. Side, 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 angle, side, angle, side, angle, and RHL. Those are your 5 ways. So which way am I going to use for this? I know 2 bits of information. I need to know a third. Of course, the reflexive property. So HI is congruent to JK. IJ is congruent to KH. And they're both the given information. And then we're going to have JH being congruent. Now this time I'm going to switch the order. Because I'm going from the 2 ticker to get down to H, I have to go from the 2 ticker to get up. So that's backwards. That's HJ. That's a reflexive POC. Now what can I do next? I can prove the triangle's congruent. So triangle IHJ is congruent to triangle. I need to be sure I pick it in the same order. So I was between 1 ticker and 2 ticker, so that would be K. Then I went to H, which was down the 2 ticker, or down the 1 ticker actually. So I got to go to J and then over to H. Why are those 2 triangles congruent? There were 2 sides here and 1 side here, so SSS congruence. And then we know that angle K is congruent to angle I. What is our reasoning going to be? There's 2 different ways to give the answer. I'm suggesting to use an if-then statement. If 2 triangles are congruent, then corresponding parts are congruent. And K and I, notice that they're both the first letters in our congruent statement, so they're considered corresponding parts. If has to come earlier, then is happening right now. Some people use CPCTC. Corresponding parts of congruent triangles are congruent. That's a shortcut for that if-then statement. Either way is correct. I would like to have you write the if-then, but I understand if you like to abbreviate it. You've got to abbreviate it with the correct letters in the correct order. Last proof. Here we have AB is congruent to CD. We also know that AB is parallel to CD. Just because it's parallel does not make it congruent, and just because it's congruent doesn't make it parallel. So they had to state them both. Now what we're going to do here is show that the opposite sides have to be parallel also. This is actually a property that we'll learn about in quadrilaterals. Well, because the 2 sides are parallel, we have our transversal, we have our zigzag. I'm positive that those 2 angles are congruent. They're called alternate interior. If 2 lines are parallel, then alternate interior angles are congruent. Then I have my reflexive property to show side angle side. As soon as I have that, I would then be able to talk about somehow I've got to get to these being parallel. Well, how am I going to show something parallel? I could show them congruent, but how could I show them parallel? To be parallel, they have to have alternate interior angles congruent. Now I can't use the original ones because we're talking about different lines. I've got to use the zigzag that is formed by these. BC and AD, they're considered to be the parallel sides, or need to be the parallel sides. So before I do that, I need to talk about those angles being congruent, which makes my sides parallel. So we start out with the given information. Okay, from the parallel sides, I said that angle BAC was congruent to angle DCA. If two lines parallel, that's what I had earlier. What am I saying right now? Then alternate interior, you have to use the name alternate interior, angles are congruent. Then of course I have my reflexive property, and we switch the letters because they're going backwards. So that should be enough information to prove the triangle is congruent. So triangle ABC is going to be congruent to what triangle? CDA. For what reason? Side angle side congruence. So now we have the triangles congruent to each other. If they're congruent to each other, then I know the corresponding angles have to be congruent. So this angle has to be congruent to that one. This one's name is DAC. Has to be congruent to its alternate interior because of the triangle's congruent. BCA. If triangles congruent, then corresponding parts congruent. If I have those congruent, then I know that my lines have to be parallel. If alternate interior, you got to name them, angles are congruent, then lines are parallel. The lines are parallel only because alternate interior angles are congruent. We don't know it before that. Good luck.